Hello all, I am Dr. Pravas. In today's class, we'll discuss about the predictive parsing. Predictive parsing. Okay, say here. Predictive parsing or predictive parser is a top-down approach. Predictive parser is a top-down parsing approach. Okay. So predictive parser or predictive parsing is a top-down parsing. Okay. So we can also call the predictive parsing. It is also called as non-recursive descent parsing. It is also called as non-recursive descent parsing. It is also called as LL1 parsing. LL1 parsing. So the another name of predicting parsing, is called non-recursive descent parsing, or we can say LL1 parsing. So what is the meaning of LL1 parsing? So here the first L, the first L means left to right scanning. Left to right scanning. Left to right scanning means suppose A, B, B. Suppose A, B, B is a string. Suppose A, B, B is a string. So the parser will scan from left to right. From left to right. The parser will scan from left to right. Means it will scan, the parser will scan the first A, then the next element is A, then the next element is B, then the next element is B. So in this way, the parser will scan the string. Okay. The second L, the second L means leftmost derivation. The second L means leftmost derivation. Means the parser will always focus on the leftmost derive, or the parser will first derive the leftmost non-terminal. Leftmost non-terminal. Okay. What is the how to derive the leftmost non-terminal? We have already discussed in the previous class. Okay. So what is the meaning of 1? 1 means look ahead symbol. This is called as the look ahead symbol of length 1. Look ahead symbol of length 1. Look ahead means it just check this variable is exist, means the variable is exist or not. Then if the variable is exist, then it will apply, means this parser will apply this particular production. How to apply this particular production, we'll just understand with the help of one example. Don't worry. Okay. The next one, the algorithm. See here. This is the algorithm for predictive parsing or LL1 parsing or non-recursive descent parsing. Generally, there are 4 steps. For predictive parsing or LL1 parsing. What is the first step? Here? If x is an element, mainly if x equal to a, equal to dollar. If x is an element, if x equal to a equal to dollar, means this element is equivalent to dollar, then we can say that the input string is valid. Then the input string is valid. What is the second step? If x is an element like suppose a terminal, if x is equal to element like terminal, a means here terminal. This one is called as the terminal. See here. If x equal to a, it does not equal to dollar. Means if x is a means terminal and does not, this x it does not equal to dollar, then we will pop x from the stack. Will pop x from the stack. Okay. What is the third step? The third step is if x is a non-terminal, then x element on the terminal, on the respective terminal like x to a, if there is some productions exist x to a, if there is some productions exist like x to UVW or x to YZ, So then push the operation. Then push. Okay. So what is the fourth step? Here fourth step is if x2a equal to blank means there is no prediction is not available, then it is called as syntax error. Then it is called as syntax error. So how to perform these 4 steps? Just see the algorithm. Just see the one example. Try to understand these 4 steps with the help of the example. This is very easy and very important algorithm. Okay. So perform the LL1 parsing table. Perform the LL1 parsing, or we can say predictive parsing also. Perform the LL1 parsing for the input string. Here input string is given what? AAA for the input string AAA by considering the following grammar, like this one, by considering the following grammar like this one, and predictive parsing table, or it is also called as LL1 parsing table. This is called as LL1 parsing table. This is called as LL1 parsing table, or it is also called as predictive parsing table. Also find the number of actions like push operations, how many pop operations, how many valid actions, like this. These are called as the push pop. These are called as the actions taken by the parser. See how to construct the LL1 parsing. See, this is the very important question here. Now we'll construct the LL1 parsing. LL1 LL1 parsing. Okay. Here now we'll create, this is a stack, this is input buffer, this is input buffer, then this is the action. Okay. Here stack initially contains, remember here S is the starting symbol, here S is the starting symbol. So stack initially contains, see this is dollar, initially stack contains dollar, and the starting symbol is here S. Okay. Input buffer initially contains what is the input string here? AAA B is here, the input string is given here AAA B. AAA B. We can directly write AAA B, then dollar. Okay. So first we'll check here S, here top of the stack is here S, and here the input buffer, the leftmost element of the given string is A. So S2A, just check S2A is which production is exists from S2A. S2, see here, S2, A small a, capital B, capital C. So this is called as push action. So S2, small a, capital B, then capital C. So this action is called as push action. Okay. Now we'll push, means the right side of this production into the stack. by replacing this S. By replacing this S. See, this is dollar. Okay, now we'll push the first C here. Then we'll push B here. Then we'll push A here. Then we'll push small a is here. Okay. Then the next element is, then the remaining string is here. Triple A, B, dollar. Okay. So the given string is here. See, the top of the stack here, top of the stack is small a, and here the leftmost element is small a. Both are matching. If both are matched, then we'll pop. Right? Then we'll pop. So then pop. So now this is dollar. This is C. This is B. This is A. So A pop. The remaining string in this A generally pop. So finally, the remaining of the string is here A, B, dollar. Okay. A to small a. See here, A to small a. The A to small a means A to, the production is here A to A. The production is here A to A. Right? Now we'll check. Now we'll push. This one is called push operation. Right? So now we'll push. This is dollar C, B. We'll push this A in place of A. Then this is A, B, dollar. Okay. See here, this A, top of the stack, and this A, both are matched. Both are matched means pop. Now we'll pop. Okay. So now we'll pop means this one. This A will pop from the string. So this is dollar. This is C. This is B. This is A. This is B. This is dollar. See here, B to A. B to A. Just check the table. B to A. B to A means B to the production. B to A. The production is here. B to small a. What? So B to small a. Okay, now we'll push this A. Dollar C, B to A will push A, P, dollar. See here, A and A both are matched. A is the terminal, here A is the terminal, both are matched. So then we'll pop. So this A will pop. So final, this is dollar, this is C, then this is B, then this is dollar. C to B, capital C to B. Just check the table. Here, C to B. C to B is here. The production is C to B. C to B. C to B. So now we'll push this B in the stack. This is dollar and this is B. So this is B, this is dollar. B and B both are matched. Since B is the terminal and B is the terminal, both are matched. Then this is the pop operation. This is pop operation. Pop. So finally, this B pop. So it is, at last it contains dollar and dollar. See here, both are dollar, dollar. Dollar, dollar means here X equal to A equal to dollar, then input is the valid in the algorithm. Since both are dollar, the star contains dollar, the input buffer also contains dollar. Since both are dollar, so the input is valid. input is valid, right? So in this way we can construct the parsing table. So this is called as LL1 parsing. Okay, now what is the question actually? See here, perform the LL1 parsing. Okay, this one is called as the LL1 parsing for the input string AAA by the considering the following grammar and predictive parsing table or LL1 parsing table. Also find the number of actions. How many actions means how many push actions, how many pop actions, how many errors, how many valid strings means valid action. See here, or accept action we can say. This is the first action. This is the second, third, 4, 5. Here 6, 7, 8, 9. So here total action equal to 9 action. So how many push actions? How many push actions here? This is one push action, second push action, third push action, fourth push action. So total 4 number of push actions. 1, 2, 3, 4. Yes. Total push action equals to 4. And how many pop actions here? Here pop action 1, 2, 3, 4. Total pop action is 4. And one action is the accept action. One action is the accept action. Sorry, 1. So 4 plus 4 plus 1 means total is the 9 action. Okay. So now we'll see one more example. See how many number of actions. The next question here. How many number of actions are taken by LL1 parser for the input string here? This one is called as the input string. Okay, ID plus ID star ID. Okay, now we'll draw the LL1 parsing here. This is the stack, input buffer, then next one is the action. Okay, here initial stack contains dollar, then S. Sorry, here E is the starting symbol. This is not S. This is the E. Okay, so input buffer is here. See here input buffer is ID plus ID star ID. ID plus ID star ID. Then this is dollar. Okay. Now we'll see E2 ID. E2 ID. E2 ID means the production. E2 ID production is here. E2 T. E2 T E prime T E to T E prime. So now we'll, this one is the push action, E to T E prime. Now we'll push T E prime in place of E. dollar. So E prime T. E prime T. Then ID here plus ID star ID dollar. T2 ID. See here T2 ID. T2 ID means T2 FT prime. So T2 FT prime. T2 FT prime means it is a push operation. So now we'll see dollar T prime. So T prime, I'll just push T prime F here. T prime F. Then this is ID plus ID star ID dollar, right? So now we'll check F2 ID. Here check just F2 ID. F2 ID is F2 ID. F2 F2 ID. Now we'll push this F2 ID here. This is dollar E prime T prime. Then F2 ID. We'll push ID here ID plus ID star ID star. Okay. So ID both are match. Since ID both are match means pop. Both are pop. So now we'll pop this ID and this ID dollar this E prime here, T prime here. Then the remaining one is plus ID star ID dollar. So T prime to plus, just like T prime to plus, T prime to plus, here T prime to epsilon, T prime to epsilon. T prime to epsilon. So we'll apply T prime to epsilon here. When we'll apply epsilon, so T prime is nothing but is just epsilon. Okay. So dollar, then it only contains E prime. Okay. Now it is plus ID ID star ID dollar. Okay. So E prime to plus. Now we'll check E prime to plus here. See here. E prime to plus is nothing but E prime to plus T E prime. E prime plus here. This is E prime. E prime 2 plus T E prime. Okay. Now we'll play. Now we'll push this one. So dollar. So E prime T plus E prime T plus T plus, then this is plus ID star ID dollar. This is dollar. So see here, plus plus both are matched. This is plus, this is plus, means pop. Okay. So pop, this one is pop, right? So now we'll see. So now my stack contains dollar E prime T, E prime T. So this is ID star ID, ID ID star ID dollar. Okay. So T2 ID, just check T2 ID. Here T2 ID is T2 FT prime. T2 FT prime. T2 FT prime. Dollar E prime T. Now we'll replace this FT prime with T. T prime, then F. Then this is ID star ID, then dollar. Then we'll check F2 ID here. See here F2 ID. Here F2 ID. F2 ID means F2 ID. See here F2. F2 ID, and we will replace this ID. Dollar E prime T prime ID. Okay, then ID, then this is ID, then this is dollar. ID both are matched, so we'll pop this ID and this ID. Pop. Okay, so then E prime T prime. E prime, P prime. Then star ID. The remaining element of the given string is your star ID. Dollar. Okay. So T prime to star. T prime to star. Now we check. See here. T prime to star means T prime star F T prime. Star F T prime. Star F T prime. Okay. Now we'll replace this star F T prime with T prime. Okay. Dollar T prime. So T prime F star F star. Right? Then it is here star ID dollar. Okay, star star both are matched. So this one is pop. Okay. Then dollar E prime T prime then F. Then this is ID dollar. ID dollar. Okay. So F2 ID. Now we'll check F2 ID here. So see F2 ID. F2 ID means F2 ID. Here F2 ID. Okay, now we'll replace ID to F. Dollar E prime T prime E prime T prime then ID. Then here ID dollar. So ID both are matched. Pop. Okay, both are pop. Then dollar E prime T prime dollar E prime T prime. Okay, so then dollar. Here T prime to dollar. Here E prime to dollar. T prime to dollar means T prime to epsilon. T prime to epsilon. Here T prime to epsilon. Okay. Now we'll push epsilon in place of T prime means this is a push operation. So this is dollar E prime dollar. So E prime to dollar. Just check the table. E prime to dollar. Here E prime to dollar. E prime to dollar is E prime to epsilon. here E prime to epsilon. Now we'll push E prime to epsilon here. So it contains dollar and here dollar. So tag contains dollar, input buffer contains dollar. Finally, both are matched, dollar and dollar. That means input is valid. Here input is valid. Okay. So now we'll see the total number of actions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So total number of actions are 17. Okay, you can also check how many. One action is called accept action. Okay, how many push operations, how many pop operations? This is just I'm checking your pop operations. 1, 2, 3, 4, 5. So here pop operations are only 5. Here pop are 5. The total is 17. Total is here 17. How many push operations? So how many push? 17 minus 5, 12. 12, one action is accept action, means 11. Total 11 number of push operations. Okay. So in the next class, we'll construct the LL1 parsing table. Okay. Okay. Thanks for watching.